Okay, so first of all, thank you all for coming. However, what I really want, and why I'm giving this talk, is so that you, I hope I'm not too loud here, so that you review the spec. And ideally, if you can, review the open source implementations of it, which are coming. So I'm Harry Halpin. I'm a part-time W3C staff. I'm a part-time researcher doing research, whatever that means. Effectively, most of the work in the W3C does not come from the staff. It comes from the working groups. So almost all of the work that I'm presenting here comes not from myself, not from W3C, but from the working group itself, which is a collection of people which you can join if you're really interested. We'd love to have you. We need more people. That's why I'm happy to see so many people here. And in particular, the majority of the work here has come from Ryan Slevy of Google, who's the editor of the spec. However, at the same point, my job as W3C staff is essentially to be a cyber bureaucrat, to make sure things go correctly. And to make sure things go correctly, one of the things that we really want is wide review. In particular, we want wide review from people who can break things. That's you. You know, we want you to try to break this. Give us critique. So it's a controversial topic, and I'm hoping to show you that it's not entirely a bad idea. Essentially, as was brought up in this great little Assange quote here, there was, a real war, as I'm sure many of you here are veterans of, to get cryptography, to the people. And indeed, it's a real victory, I think, of the sort of global cryptographic community and the global hacker movement that indeed strong cryptography is in browsers and available to everyone. However, at the same point, it did occur to us at W3C that while it was available, it wasn't very easily available to web app developers. And maybe it shouldn't be. We'll discuss that. But maybe it should be. And we're going to argue why that indeed could be the case, although it doesn't solve all of the problems. So first thing, I don't know how many people here are familiar with the W3C and standards bodies in general. Again, like many great things, the web started as a sort of, for lack of a better word, a cheap hack, but it had a good idea in it. And the good idea was essentially that it should be a universal information space. So all information would essentially share the same name. And this name would, of course, be based on URIs, the acronym formerly known as URLs, Uniform Resource Locators, now Uniform Resource Identifiers. So of course, one of the primary issues, of course, with the pre-web internet was that each protocol had its own particular scheme. URI sort of nicely unify that. Hacked up as a quick prototype in halftime, put a simple hypertext system on top of the internet, threw some draft specifications out to the IETF, and voila, the web was born. I mean, fact of the matter is, Tim Berners-Lee's web browser was quite cool. It could do reading and writing data, more like a wiki, better than a wiki. But the fact of the matter is, very few people used his code base, partially due to being an Objective-C. What actually happened is, of course, the web took off via Netscape. Academically, not a success. Papers rejected. It was actually too simple to be interesting. Didn't even guarantee two-way link consistency. So 404s were considered by the academic community to be a ridiculous simple error, which why would you rather have an application that didn't let you go to broken links? And of course, users in the original web design were also treated the same. That's the heart, or one of the hearts, of the REST architecture. And thus, for purposes of scalability, in the original web design, there were no cookies. However, there was also no security. Now, this was all sort of done on purpose because, of course, the web being designed in a scientific lab, in the early 90s, it was sort of par for the course that things would be transmitted in plain text, that there wouldn't be very much in the way of access control, that you wouldn't have a giant billion-dollar industry of tracking users. This was all sort of not foreseen at the time. And therefore, it's kind of put the web in a funny place, where almost immediately after it started getting big, people started trying, of course, to sort of essentially put security on the web post hoc, which is always somewhat problematic. And there's various attempts to do this, some of which are currently being refactored. HTTP 1.0 has authentication, sending the password across in plain text. This was replaced by MD5-based digest authentication in '93. Of course, TLS tacked on in '95-96. And originally, the web was not supposed to have any sort of programming languages on board. There was the attempt, of course, by Java and Sun. But essentially, Tim Berners-Lee always felt that one should, as I quote, use the least powerful language suitable for expressing information, constraints, or programs on the World Wide Web. So ideally, use documents, not Turing-complete programming languages. Of course, history went in a completely different direction. So the fact of the matter is, the web is effectively a JavaScript virtual machine, effectively doing what Sun hoped actually Java would do. And thus, we have a sort of massive security problem. And this is what, of course, we're trying to fix. Now, there's many different ways to fix it. One is you could not use the web. I know there's advocates of that. Unfortunately, those questions are off subject for the time being. But you could also try to fix some of the web. And there's different ways to fix it. And one, of course, is perhaps the most instantly effective is hacking on popular open source code bases. Most of the browsers are open source code bases. However, there are, as we know, non-open source code bases, proprietary browsers on the internet. Microsoft Explorer comes to mind, of course. And thus, another way to tackle the general web security problems is to operate in terms of specifications. The meta layer above code of which both proprietary and free and open source software can write to. And of course, there's so many standard bodies out there. That's the great thing about them. There's so many to choose from. Internet Engineering Task Force, perhaps the oldest out there, which the original web specs came out of, and which has perhaps most of the security work going on it right now, is composed of individuals. Free form, anyone can show up to the mailing list, discuss things, not particularly formal. On the other end of the spectrum is the ITU, I'm sure everyone is familiar with now after perhaps not knowing it existed for a long time, which is composed of nation states and representatives, somewhat formal. And the World Wide Web Consortium is composed of organizations. It was, of course, convened in 1994 to keep the web unified, has too many ad hoc features, started getting added, blink tag, the browser wars, made from Microsoft Explorer. In fact, if you think JavaScript is bad, Microsoft Internet Explorer still supports VB script. I don't know if anyone's, there's not been like a particular interesting security study of VB script. I think maybe someone here should do it. It would be, I'm sure, fascinating, and maybe you could convince someone to stop supporting it. But regardless, we saw a lot of things being added to the web. And Tim decided to take some action, form the Web Consortium. Essentially, it's global, headquarters in various places, US, France, Japan, offices around the world, including one here in Germany, and an independent staff to try to keep the sort of bureaucratic process neutral. Because the thing about standards is, of course, if you're not careful, large companies with lots of money could possibly, or large nation states with massive geopolitical alliances, could undermine the process and get not so nice things passed. The reason it exists is basically so we want you to be able to implement things without having to worry about paying licensing fees or being taken to court. And that's crucial, of course, for free software programmers and small businesses, even though, of course, the consortium, we're composed mostly of larger organizations. And there's a reason for that, because most small businesses and open source folks don't have IPR, right? So the IPR is really important. Unfortunately, it's just the reality we have to deal with, that you can actually be, forced to pay licensing fees, or various people can attempt to force you to pay licensing fees. You get involved in sort of nasty court issues. We try to prevent that because all W3C specs go through what's called the W3C royalty-free license. And while any organization can join, and if you have a company that you think that may be a member, we have a list on the internet, and you can always ask me. However, we do, and this is really important, let individuals participate in working groups. If you can demonstrate that you're committed to the goal of the charter, that you're some sort of expert, and I'm sure a lot of people here in the audience are experts, we do have a very open invited expert process. In fact, I'm hoping to get a few people asking me afterwards that they would like to become invited experts and join the working group. And furthermore, the fact of the matter is the WC has something particularly interesting which I really want to drill home here. It's a process point, but it's an important process point. There's various levels in the standards. We'll go through those later. But one of the reasons why we have these levels is various to finalize things, lock them down, get the IPR commitments. That's what makes standards so slow, slower than, say, open source hacking. Because we have to lock down IPR commitments. That involves lawyers. That slows things down. However, at the same point, we do have a very open process such that anyone can join our comments list and send in comments. And that's really important because up until the last call, we have to respond to your comments. So that's actually, I think, in all of our work being done in public mailing list, etc., minutes all made public, that we really want, and we're quite disappointed when we don't feel that we have wide open review. And in fact, that's why I'm here today, because we've been around for a few months and we haven't had, in my opinion, enough review. And the fact of the matter is working groups operate by very tight time schedules such that by next Congress, it may be too late. So the web security model, or let's say it's evolving. So there's a lot of things that I'm not going to talk about that we're not going to fix. And because these things we're not going to fix, at least right now, at least within this working group, will be for the foreseeable future pretty insecure to build web applications. So we're not, I want to be very clear here because there is some, how should you say, Twitter misunderstandings about the Web Crypto API. We are adding new capacities to web browsers, new functionalities. We are not in any way saying web apps can be secure. That's the sort of long goal. And there's very many ways which we are not tackling which currently make things insecure. And I'll just give a quick list. I'm sure people here are familiar with these, but nonetheless, just so you have a large understanding of how many different things are completely not particularly well standardized. There's, of course, the incompatible parsing of URIs, HTTP requests, different kinds of slashes, different kinds of quotes, God help, internationalization. Quite messy quite quickly. HTML5, WhatWeG, and IETF are all working on these. There's very strange inheritance patterns with same origin and about blank and many other places. We just don't quite even have the same origin policy completely consistent. Of course, and the same origin policy for web apps came after cookies, so we don't have this. That's not lined up either right now, although there's proposals to line it up. We don't have very good, there's no good sandbox in JavaScript right now. JavaScript is what it is. It was put in. It's now very popular. JavaScript is not controlled by Web Consortium. It is being revised in ECMA. If you're interested in fixing some of the larger security reasoning issues in JavaScript, which desperately need to be done, please talk to TC39 at ECMA. There is some great experimental work on this. Kaha script from a while back by Ben Laurie. I'd highly like for people to look at. Network attacks on unencrypted HTTP connections. Particularly, this is just really slightly fatal for a lot of folks and will continue to be fatal until it's fixed. There are various patchworky kind of ways to fix it and various more principled ways. W3C is working on some principled ways. I recommend people take a look at content security policy, although it does fortunately often involve rewriting your entire website, and HTTP strict transport security. Of course, and then there's, even assuming that works, there's the massive hole in the CAs. Right, so we're familiar with the server CA problems. There is a draft, again, Anna Langsley Ben Laurie draft on IETF certificate transparency, about to become an IETF working group to basically make the append-only log of CAs. I know there's other browsers with other ideas here. There's notaries. There's various concepts out there. Nonetheless, this is something which clearly has to be fixed in order to guarantee some level of security. There's very basic things, fixing things which have just been broken for 10 years. Fixing broken crypto in HTTP auth, for example. So the IETF is reopening the HTTP authentication working group. Of course, terrible parsing. Sometimes parsing is just really difficult. Browsers implement it occasionally a bit differently. Sometimes the standard's hard to read. One of the most interesting working groups, which I'm not going to talk too much about, but which I do want to highlight here and think people should also review, they're almost done, but that you can still get your reviews in, is the IETF JavaScript Object Encryption and Signing Working Group, the Jose Working Group. They're going to take all our wonderful key formats, which we know and love, and put them in JSON, which is easier to parse, of course. And there's some things that we just can't do as a standards body, one of which is, of course, user interface issues. That's a place where browsers compete. We can beg and make recommendations and say something happens here, but guaranteeing what color, of course, the UI toolbar is beyond us. So just to be very clear, the Web Crypto API is not actually part of what you would traditionally consider a client-server web security model. That, to be honest, still dealt with by TLS. However, it does add new capabilities. These new capabilities are interesting. They're interesting because you have, for example, now with web apps, you have often multiple web apps talking to each other through multiple channels. So you have multiple hosts involved, tokens being shipped around. I would say take a look at OAuth 2, for example. And you might want to sign these tokens. You might want to do some guarantee of authentication over tokens across multiple web apps. That's basically impossible to do right now. And this is the sort of thing that we hope the JavaScript Web Crypto API can address. So just to continue with there's a really great blog post by Matasano Security on JavaScript cryptography considered harmful. And he's essentially right, given his presuppositions. But I think we want to look at his presuppositions very carefully and figure out which ones can be fixed, what ones need to be fixed but we're not fixing right now, and which ones are de facto impossible to fix. Okay, so secure delivery of JavaScript to web browsers is a chicken-egg problem. If you don't trust the network to deliver a password, you don't trust the server, you can't trust them to deliver code. Well, okay, so we're not solving cross-site scripting, cross-site request forgery. Again, we are hoping you use TLS. We really are. You really should. Ideally 1.2. And we're hoping that you use CSP and HSTC to start. However, at the same point, we are making some assumptions. And one assumption is that there are hosts who you can trust. So if you're in a sort of attacker model where the host, the server, which I know quite a few of you here probably are in this model, is never to be trusted, then we don't expect you to use this API. Good luck. There's reasons why I think maybe you should trust hosts, and we'll go into those later. But we're dealing with a world where that's a valid assumption. The other is that browser JavaScript is just hostile to cryptography in general. But again, we're going to assume that you built your web app correctly. And we're going to assume that essentially you haven't had some sort of cross-site request forgery happen. Is this too hard as it's impossible? Well, yes. I mean, you could make an argument that the web should just not be used at all. And I think, but the fact of the matter is people are using it. We have to deal with that situation. And a really determined attacker can also, Trojan your desktop machine, seize your device. These are all, we have to phrase the problem here we're going after. And we understand that the malleability of the JavaScript runtime makes it essentially impossible for JavaScript from its particular runtime environment in a particular tab to understand the security properties. So for example, has this particular crypto method been overridden? And JavaScript currently can't tell you that, and we're not solving that problem. I do think that problem should be solved. At the same point, that's outside of the scope of this API. However, Matasano brings up a number of points which are fatal. And these are things which, while just as fatal as the things that have been mentioned previously, these are things that are within our scope to fix. He says, well, look, this is a secure random number generator is missing. Okay, that's something, we have TLS inside browsers. We can expose secure pseudo-random number generators. Secure erased with garbage collection, that's beyond the scope. But functions with known timing characteristics, constant time functions, that's something we can expose. Secure key store, a bit trickier, but something we give a shot at. And we understand that, 10 years from now, people will still be running old browsers. At the same point, I think the general statistics of browser adoption show that there is increased movement towards newer browsers. IE6, IE7, these have all become less and less of a problem over time. So of course, if you're using a browser which hasn't been updated in a long time, deal with some proprietary firewalls, which hasn't been patched, we can't solve your problems. So we're going to assume that you're running a decent browser. So yes, but perhaps most importantly, we are just going to assume that people will keep using JavaScript. And I think there's some empirical evidence there. There has been, within the last year, an increased amount of people rolling their own crypto in JavaScript. This is perhaps not a good idea. I'm no cryptographer. I wouldn't do it. Highly doubt anyone can do it right. There was the whole sort of somewhat unfair attacks on CryptoCat, for example. Again, I think we need to, as a community of people who are interested in making the web better, provide the cryptographic primitives needed to make use cases like multi-party OTR be done securely in CryptoCat. Now, CryptoCat is still going to be in a plugin because you could, of course, you don't be vulnerable to all of the various attacks that we mentioned earlier. But at the same point, in the words of a certain security hacker who kind of pushed the concept for the W3C to do this, we know the browser has the good stuff in it. Just let me get at that. So again, things we can do. Constant time functions for cryptographic primitives, cryptographically secure pseudo-random number generation, and secure key storage. And I'm also going to argue, now a lot of people would say, well, why don't you just use a plugin? So it gets it, and plugins are rapidly, not, how to put this nicely, they're being phased out a little bit. And so again, JavaScript is a somewhat terrifying Turing-complete programming language. So is all the plugins. But the fact of the matter is code is code is code. Okay? There are often more 0 days bugs and various other exploits in plugins than in, let's say, WebKit and Chrome. Why is that? Not because of magic, not because the language is worse or da-da. It's because there's just, in general for plugins, there's less wide review. And one of the strengths of a standardization process is that specifications and the open source code, which implements specification, can get the wide review. In fact, we have a whole organization which is coming begging you to give us wide review. And at least also, when you deal with APIs and you deal with specifications, even broken ones, they're known factors. And that's often not the case with plugins installed over the web. And web apps, of course, can be easily and globally updated via the host, so you don't have the sort of window between your exploit and your plugin and your, of course, plugin update. So that's where I'm going to do a very dangerous move, something which I'm sure a bolt of lightning will come down and destroy me, of disagreeing with both Bruce Schneier and Patrick Ball over CryptoCat. So just to quote, CryptoCat is one of a whole class of applications that rely on what's called host-based security, big quotes there. The most famous tool in this group is Hushmail, and you can read the rest of the quote, but I'll detail below. But a short version of this is that one of these applications, your security depends entirely on the security of the host. This means that CryptoCat is no more secure than Yahoo Chat, and Hushmail is no more secure than Gmail. More generally, your security in a host-based encryption system is no better than having no crypto at all. Now, as pointed out by Thomas Rosel, even in a perfectly designed web app, the behavior as regards the DOM is completely controlled by the host. And that's a feature, not a bug. I would actually claim that, and this is one of the reasons why I'm working on this, is that host-based security is not always a bad thing. So how many people here have flown into the USA recently? Okay. How many people have been stopped at the border into the USA recently? Okay, see, a few. How many people have had their devices seized at the USA border? Okay, or the UK border. Or, so what I'm saying is, I personally, in my life, I don't have a problem. I mean, perhaps my server's compromised. I've done server maintenance for a number of years here, and I've had, one server seizure. which I think is a good sign, because if they seize your server, it probably means it's not compromised. At the same point, what's generally happened in my life is that my main problem is my client devices are seized. Not just, and this happens, edge case for most computer people, nor as a normal case in some situations, right? So in Syria, they go into your house looking for your Facebook, right? So it's very easy in general to seize client devices. And I do keep, use whole hard disk encryption, try to use a long password, et cetera, et cetera. I don't trust that if my device gets seized, to be honest. However, in my personal life, I've put, what I normally do is I put things up in the cloud, cross fingers, get new computer, life goes on. So a day or two where you can't check email, but it's not that bad. So I do want to just argue that host-based security is not a terrible thing, primarily due to clients' device seizures. Also, as of course the CCC has demonstrated, increased targeted trojaning of client devices. And to be honest, mistaking proximity for security is absurd. I can give a whole rant about Freedom Box. And software isn't self-healing. End users in general, people here are very talented. Many end users are still using Yahoo Mail, right? So we have a responsibility if we really want crypto and some form of stronger security to get into the hands of actual users. I think, and I have changed my mind on this within the last few years, I do think that we have to admit that a host-based security can work if you have a trust network with the host. That's a big if. I have trust networks with several hosts. I hope people here do. And again, even if you don't buy, even if you think the host is completely your enemy, you can still enable use cases such as multi-channel web app communication across multiple origins. This sort of loosely coupled design we're seeing more and more on the web. So the web is not simply server, client, web app. We're seeing networks of web apps connected in increasingly complex ways, sometimes enabled by W3C specs, post message, and being able to sign and do some guarantees over integrity and authentication here is useful. So here's some of the use cases the working group thought up. We'll see how many of them can actually be done. The fact of the matter is, one of the things that's really motivating this working group is a use case called the Korean banking use case, which we can't actually solve, but we can kind of help a bit. So, in some countries, they somewhat correctly surmise that the security in the web isn't that hot. And then they basically mandated plugins. So this is actually in Korea, South Korea. There's I don't know if we have any Koreans here. They seem to be very interested in this API, that we try to convince them we can't solve all their problems. Where essentially an ActiveX plugin was mandated, therefore trapping anyone who wanted to do any sort of financial transaction in Korea into using Microsoft Internet Explorer. And the ActiveX plugin itself, like again many plugins, had its own set of security problems, therefore not making it entirely more secure than just using a web app. And thus, there's a big, it's even an election issue in Korea, desire to redo the authenticated banking services, better multi-factor authentication in Korea. So again, we're hoping that some of this can help bolster username and passwords. Ideally, proving that user has some access to secret keyring material. That was actually my initial sort of motivating use case, and there's some interesting ethical questions there you think about deeply. After all, if passwords actually work, then certain practices may not become much harder. Protected document exchange and cloud storage, being able to store documents in the cloud. Now you can of course say, well look, a malicious web app can then just, of course, try to seize your key material, At the same point, in my experience, server seizures can be a problem. Having things encrypted with the key on the client to would help, and that's quite hard right now, unless you can really make the user set up Enigmail and various other things correctly, which they tend not to be able to do. Of course, the very common case, very relevant for the EC with the common e-signature directive, document signing. A case which, interestingly enough, interests several large vendors of various kinds of data integrity protection. Just to go through this really quickly, server signs some data, with a private key held only by the server. It's cached. Web app then kind of checks that when it gets it back out of local storage. And of course, the CryptoCat use case of some kind of secure messaging. So what we have is we have a home page, which if I have internet should work. The home page is where you should go. It lists basically the working drafts, the drafts of all the documents. We have our teleconference lines, which you have to be a working group member to dial in, and our mailing list, which we highly recommend you look at if you want. And of course, the most important part, why we're having so much trouble finishing, open issues. So you can see we have 30 open issues, of which we've closed only 10. And some of that's just because it's hard. And we need help deciding technically what to do in some of these cases. Always, when reviewing, tell us which version you're reviewing of the spec. In general, the working draft represents consensus the working group to publish. The editor's draft is just what the editor is doing to try to solve things. The editor is very bright, particularly in this working group. Ryan Slovey's done 99% of the work. So please, I think it's better to comment on the editor's draft if you can. We also have use cases and a key discovery document. We'll go through these in a second. So far, the working group, the idea came out of 2011, a public workshop. W3C does run workshops. They're free. Anyone can present ideas for standardization there, assuming they're on topic with the workshop. And we have the normative API, which hopefully means everyone implements. We're going to try really hard on that one. We can't guarantee it. Use cases, which are non-normative, but just explain what our sort of success criteria is in terms of use cases. Key discovery, which we recently split from the main spec. And test cases. We will have a public test suite. That doesn't exist yet. And everything can be checked out. Okay, so you can check it out. All ads are public. And here's what we're trying to solve. So we are not rewriting crypto in the browser, thank God, because it's already been done quite well by very talented people. We do have a large list of features that we want. We want, of course, all the basics. Most of the things that PGP can do. Generation, encryption, decryption, key deletion, signature generation and verification, hash message authentication codes, key transport and agreement, strong pseudo random number generation, key derivation functions. This one we're trying, we haven't quite there yet. Key storage and control beyond the lifetime of a single session. Again, controversial. Asynchronous, very important due to issues with JavaScript. And of course, we don't want secret key material to magically escape everywhere, so keep it locked down. And cover, of course, both symmetric and asymmetric crypto. There's a lot of stuff which we're thinking about covering, of which we have not done because we just only have so much time. Control of TLS session login and logout is not done consistently across browsers. Derivation of keys from TLS sessions would be great. Channel binding, generally a good idea. I would recommend people look at the origin-bound key work of Dirk Balfans and others. Trying to make things simple. Simplify data protection functions. Multiple key containers. Key import-export we are working on right now. Common methods for accessing and defining properties of keys, that's still being worked on. And of course, client cert. That's possibly a whole other API, which we won't get to anytime soon. And we have a very tight, oh dear, we have a very tight time schedule. So basically, we need your reviews by May. So I'm going to overview very quickly what the API does. We have pseudo-random number generation. We have keys, JSON object for key materials. We have a finite state machine, which defines crypto operations. Asynchronously, tells you when they fail, tells you when they don't. We do not tell you which algorithms to use. We give you the ability to create an algorithm dictionary and to register new algorithms. This includes broken ones. It's useful for backwards compatibility. We include all the basic functions, and we're working on key storage. And currently, key storage is a bit of it's dangerous. We're currently doing key storage. This was a recent change using structure clone, i.e. what would now be IndexedDB. The reason for that, rather than creating a whole nother key storage location, is simply because we want keys to work kind of like, I know it sounds terrible, but life can be worse than cookies. Right? We don't want you to be permanently tracked by your keys. So we can't imagine, and Wendy Seltzer, who's a great, the other W3C staff contact, who's a wonderful lawyer and very well known for all sorts of things, much smarter than myself, she pointed out that, of course, you can do fingerprinting. You can detect which browser implements which algorithms, and that's simply enumerate this. You have a fingerprint, but you can fingerprint browsers many other ways, so we're not going to lose too much sleep over that. If we do allow keys to be permitted to be used between origins, key derivation, all this stuff can go wrong. We can do this very easy tracking, as dangerous as cookies. But we should at least, I think, make it not more dangerous than cookies. So perhaps the thing that everyone's been waiting for, as we all know, math.random is a terrible, terrible thing. We have replaced it. This was due to Adam Barth, originally to what we G and now sort of adopted, with a random source interface. And again, we will work with web workers, so this will allow us to do nice sort of background scripts. I don't know if people here looked at web workers. Random source, we cannot guarantee that will be strong, but we are recommending, and we do think the browser vendors will listen to this, that you do call strong pseudo-random number sources from random source. We have a key interface, and again, none of this is rocket science. This is more or less how I think many people would imagine a JavaScript crypto library looking. We will have, of course, types of keys. Distinguish, of course, secret keys from non-secret keys, public keys from private keys, keys that can be extracted. Obviously, you don't want your private secret key to be extracted from ones that can't. And that's quite important, of course. And while this is, again, something we're still working on, when we have some operation which involves some private key material, we cannot make guarantees about user interface, but we can specify that something should happen. Just as when you download a file, there's a open the file and a window appears. We want some sort of, do you really want to do this? Prompt to appear in the Chrome. I know, it's tricky. We're trying to work on it. Browser full screen mode and stuff, again, makes this difficult. We have a number of open issues. One open issue, which I'd like to hear some advice on, and we were going to try to move a bit quickly here, is key tainting. So, we're allowing people to make all sorts of different keys for all sorts of different key operations. And, of course, sometimes when you reuse particular keys, reusing RSA keys, for example, things can go wrong. And what we are determining, should we allow, right now we don't really have a clear way to record in some sort of a pinned-only log how a key's been used. And we're trying to decide if that's really worth doing or not. I'd be interested in hearing if people think it is. Key discovery and naming. This is, of course, what it is. Should we allow people to name keys? Add customizable attributes, including perhaps globally unique attributes. This is something which we split off. It's in another spec. It's an open issue if we want to keep it or not, but I do think it's a very interesting idea. It will allow, the main use case motivating this is pre-provisioned keys with symmetric key exchange. And of course, the heart of the API is crypto operations, which basically puts all your crypto operations in a big stack, goes through the stack. And if something goes wrong while you're because crypto operations, of course, are heavily computationally expensive, we fire off an error message. But there's a number of open issues here. So while it's pretty clear how we would support very basic things, we're not sure how we should support key wrap and unwrap. Should key wrap and unwrap be distinct operations, or should they be supplied to import and export? And we haven't really sorted out key derivation yet. We have some ideas. They're here. This is the interface, the key derivation's down there. But we haven't really decided if key derivation is really, if that's the right way to do it, how it should be parameterized. So these all sound very basic, but they can have very big, security risk if it's done wrong. And of course, what can of course really be done wrong is the use of the algorithms. And this has been quite controversial, but we felt that backwards compatibility was important. So essentially, there are two camps, one of which says that you should basically never let people use broken crypto which has known security weaknesses. Of course, a lot of known security weaknesses come from combinations of different primitives. But regardless, because we want a backwards compatibility with everything from GPG to SSH, we decided that we should allow Basically, we were not going to tell you what crypto you can and cannot use. We will define a few. We will have a, hopefully, well, we haven't sorted this out yet, a registry which allows you to define your own. And again, this API, if you looked at how crypto operations worked, it's pretty low level. It's not very high level, not particularly web app user friendly. For developers at least. And the reason for that is that we felt it would be better to basically put forward the primitives that people could use to build all sorts of things rather than tell people this is the best thing to do. And this is primarily just for the obvious reason that the best kind of crypto, there will be new attacks in the future. And we don't want to backwards constrain people. We want to keep people to use whatever crypto they feel is safe. At the same point, we're not sure if we should maintain that list. Should IANA maintain that list? Should the IETF, CFRG retain this list? This is up in the air. I'd be interested in opinions here. These are things that we're including. Of course, RSA, including with a optimized asymmetric encryption padding. Elliptic curves, this is just necessary for mobile devices. We're not going to get away without it. Of course, there's various debates about various kinds of curves. We'll leave that to be. Of course, advanced encryption, various cipher block chaining modes, including Galois. HMAC, Diffie-Hellman for the symmetric key encryption case that we brought up earlier. And various key derivation functions, including concat and password-based key derivation, which we haven't quite got to in the spec, but we're working on. And then for people to say, well, how would this look? This specification has some examples of how it would look. So you can see, and now I'm going to try to wrap up here relatively quickly with some larger questions, what it would look like. You basically set up some key parameters, you pass them, give it to a dictionary, generate a key, use that dictionary. Then, it's messy but fairly straightforward. Then you can basically sign data using, of course, relatively straightforward functions. And you have essentially preset error message handling. So again, and then we are also, again, handling symmetric encryption. We're allowing you to specify, hey, I want a random initialization vector. And I want to use cipher block chaining with advanced encryption standard. And we're going to wait for this to complete before doing the next step. So again, all fairly straightforward, but things that you cannot really do safely even on the level of JS inside browsers today. And now for the future, again, you may find that the Web Crypto API, that's really boring. And to be honest, it is a crypto API. We have a lot of crypto APIs out in the world. We hope that people use it and they like it. We are hoping to make a more high-level one based off the Google work on Keysar, Mozilla on DOMcrypt, Stanford JavaScript crypto library, but we thought a low-level one was the first good step. We may or may not squeeze a high-level API in before working group's over. But if you just want updates about when new security-related specs come out, these are public mailing lists. Join the Web Security Area Group list. Join the Web Security Interest Group mailing list. So you get both the IETF and W3C. If you're really interested in more authentication, HTTP auth. Really, 8 proposals on the table. They need some sorting. WebRTC, peer-to-peer based communication in browsers. Very interesting, very useful for media streaming. SysApps, we are not dealing with smart cards in the spec, although we're hoping that some of the key material can be eventually gotten from smart cards. But smart cards, often keep everything on the smart card. So there will be a new smart card API coming in the future. NFC. Top topic of a lot of hacking recently. NFC working group starting up. Web App Sec, if you're interested in the issues around cross-site, general web application security, look at CSP, new version 1.1. Cores, all of this stuff. In fact, they're even making a security architecture document. And a lot of possible work in the future. Right now, again, the key material is still accessible, minus the secret and maybe some user boxes, by the host. Should we have it so there's a kind of key material that the host can never access? And that maybe we can encrypt and give that encrypted data to forms pre-encrypted? Should you have this material be outside of the JS environment on some level, on a really strong level? I would think so, but we haven't really got consensus yet on how to do this. There's been various talk about various forms of web identity. I'd be interested in hearing what people think that's a good idea. Various moves towards and allowing open social-based applications, social web. making that standards-based, or at least making it easier to discover the fragmented standards which exist. Microcredits, web payments as we like to call it, a hot topic. And of course, there will probably be another version of the spec. Although we would like you to give the feedback now, so we don't have to make it so quickly. And also, lastly, I just want to say, with great power, comes great responsibility. Cryptography can be used for many things. We can, of course, and a lot of it, people have very different places where they fall ethically. One of the big topics, of course, W3C exists to convene industry. We convene industry on all sorts of things. Some industry players, of course, are interested in what they call digital rights management. Nonetheless, while of course crypto can help enable various kinds of content control, I think it's a worthwhile trade-off to allow primitives that protect unauthorized access to content, both from organizations, governments, and also, but you could see how it could be used to prevent access from users. We want to defend free expression, but if we want to defend the free expression of human rights activists, we're also allowing tools that some people may consider criminals to use. Authorizing transactions is useful in many, many different contexts. And I guess the final thing, and then we take some questions, we have collectively failed to get cryptography in the hands of ordinary users. The kinds of cryptography that most users encounter in their daily life is TLS and the CA system. Okay. We have to get this better. We need to make the web as usable as possible. Moxie has a nice term called key invisibility. I think keys should be, public key crypto should be enabling many kinds of applications that currently it's not. Ultimately, users shouldn't have to worry about key management, install lots of complicated plugins. Users should just use it, should just work, and we should have a secure web infrastructure. But the fact of the matter is, web security has been bolted on ad hoc. It has recently been upgraded after almost 10 years of neglect. A lot of fundamental web security work, last was kind of looked at in '96. And does this mean we shouldn't use the web? Well, you could say that, but I also think it's really up to us to make it better. And I'm offering you a very clear process for how you can help make it better, and a very clear API, which really needs review. And that's only the tip of the iceberg about what needs to be done. And then thanks particularly to Ryan Slevy, David Dahl for having the idea, Virginie Galindo for working on it, Wendy for being an awesome staff contact, Thomas Rosler for being an awesome boss and pushing this forward, Arun from Mozilla for supporting the idea and also editing the use cases, Eric Rascola from, of course, TLS, giving great comments, Wante Chan, NSS, great comments, Mark Watson, Zuku, Nadeem, Mike Jones, Richard Barnes, who's currently making a polyfilled version of this called Polycrypt, which should be out very shortly. And of course, ideally, you too can join this list of people inside the working group. Please review the specification. Thanks a lot.
Okay, thanks to Harry Harpin. So he will take answers now, questions. So we have the audio angels with the microphones over there.
Torches.
If you're, please leave quietly when you're leaving. So we have the first question over here.
Yeah. Hi. I have a question. Here. The other one.
Oh, okay,
Hi. Yeah. So in the beginning you told us that it's a problem to verify if the JavaScript is trustworthy.
Yes, this is a very large problem.
Yeah. So, and then you told us about a lot of modifications in the JavaScript itself. So do you have plans for modifying HTTP or HTML to say, okay, I only allow signed JavaScript, like I can download a signed Debian package or a signed RPM?
Yeah, so okay, there's different ways to approach this problem. Although I'm not personally involved, I don't know. Ideally, Thomas Rosler would be here and tell us what's going on. But
please respect the question and answering session.
Web Application Security Working Group is looking at signing, various ways of doing signing and an HTTP level and caching on that level. Obviously, there's lots of proposals on the table. People need to go through them. There aren't enough eyes looking at it. That is also, though, for the JavaScript runtime in general, a really hard problem. That's a problem which I would love to see the W3C tackle in conjunction with TC39 of ECMA. Right now, we do not have agreement from the vendors to tackle that problem. However, I agree, until that problem is effectively tackled, the web is going to have a very large security hole, and that's just due to how the JavaScript runtime environment works. So the answer is look at WebAppSec, and then ideally encourage ECMA and W3C to work on this.
Thank you. Next question.
Hi. First, thanks for a great talk. It was very inspiring, and I think the topic is very ambitious. So yeah, so good work.
Yeah, well, just exposing stuff in TLS, but yes, it is ambitious.
Two questions. One, you mentioned some people from Google and from Mozilla that are involved in the work. Are there any other browser vendors that are interested in the work? So do you think that actually it will be deployed in
Microsoft is part of the working group.
Okay.
So we have
what about Safari, and what about Opera?
Opera, yes, Havard is part of the working group. The only large company which is not part of the working group, which has a well-known browser, is Apple. Okay. Everyone but Apple's in the working group. I mean, you know, I'm okay with that. You know, sometimes people implement things after the working group's done. You know.
Okay. And second question:
WebKit, you know, fine.
What about TPM? Is TPM part of this spec in future or right now, or is it completely out of the scope?
Right, like I said, we are trying to keep that out for the time being.
Okay.
And there is other working groups which are going to be closer to that. And you could imagine some of that maybe being jinked on top of pre-provisioned symmetric keys. But we're providing primitives. How people use them, something that we can't actually control. At the same point, I think if you're really interested in smart cards in particular, that's going to go on in what's called a new working group, which is the sysapps working group. And they are starting either right now or very soon.
Thanks.
Next question comes from all the way to the right, or your left.
Yeah. Hey. As I understood, you have implemented support for some very low-level cryptographic basics, and I just wanted to ask about have you put any consideration into the aptitude of the web app developers in their crypto knowledge? For example, you allow people to pick their own IV, and if you do that in a wrong way, like picking the same all the time, then you will have an insecure system. So you're putting a lot of trust in the developers of web apps who might not know a lot about cryptography.
So yes, the idea for this API was originally to do a high-level API that was kind of idiot-proof. Then we realized there are many different kinds of idiots in the world. And it's hard to idiot-proof everything for everyone. However, we do believe there is an optimal idiot-proof API out there. We are not quite there yet. So we decided to work on the low levels first to allow people to compose higher-level idiot-proof ones if we run out of time. But ideally, we will have something like a high-level API. We're not sure it's going to be normative. We're not sure how well it'll be implemented. The low-level API is looking good. High-level API, more, however you say, sketchy. At the same point, we are well familiar with this problem. The person who originated this idea, which is David Dahl, who did DOMcrypt add-on for Mozilla, works for Mozilla. David Dahl has registered www.footgun.com, and we do plan to use it. So.
Yeah, this high-level API, will that reside in the browser, or will it be something like jQuery?
Yeah, that's what we're kind of. I mean, again, the high-level API is something we haven't had time to look at yet. What we would like, again, there's Keyzar, there's DOMcrypt, there's NACL, there's a number of good Stanford JavaScript, there's a number of good high-level API libraries out there. What we'd really like someone to do is someone with a spare few hours to sit down, look at a bunch of JS code of web app developers actually screwing things up, which would be great. We need some actual empirical evidence here, and figure out which of the patterns used in this high-level API will prevent those screw-ups. The one quasi-decision we have on a high-level API is that we will use most of the high-level APIs kind of do more or less the same thing, but they have very different formats for input and output, and we will use the IETF Jose formats for input and output. So we will let your key be shipped around in JSON rather than ASN1, which we think is healthier.
Next question is from the middle of the scene, audience.
Hey, in the middle. Hey, so I like my crypto things compartmentalized, and also my identities, to the extent that I like to run them in external hardware, you know? How much will that be possible? Because I don't really want to trust my keys to the browser. Will it be possible to run it through GPG, to a smart card, or to some kind of direct external high security module or something like that?
Yeah, I mean, there's a lot of people who want that. David Dahl, who did DOMcrypt, is now working on experimental Mozilla extensions, Nulltext, which allows that. Smart card vendors want that. A lot of people want that. Right now, just for our own sanity's sake, we have private keys, but again, it could be screwed up, right? So you could put your private key somewhere, say IndexedDB, you somehow screw it up, you know, IndexedDB gets compromised, thus your private key gets compromised. And that's, of course, dangerous. It'd be better if there was another container, smart card or something that your browser just can't get to at all, even if things get really screwy. We have that in the charters, and maybe we might do it list. That's multiple key containers. We haven't got there yet. And the smart card API, because smart cards are quite messy. And I assume there's quite a few people here who have messed with them, but they're tricky. That's a different working group composed of smart card experts. But again, this is something we want to enable. A lot of it comes down to time, and a lot of it comes down to human power. And we really need more human power on this. The editor is doing a lot of work. It needs more review. And we have if someone has a really good idea for how to do multiple key containers, and you want to talk to the people, Kai and other folks, who work for the browser vendors, they're completely accessible. What really is needed is good ideas that we can get consensus on. And that's why we aren't doing some of this stuff. It's not because we don't think we don't want to. It's just that you have to have something implementable that we can get agreement on.
Just a reminder, we have 5 minutes left. We still have some questions. Do you have a question in the back?
So thanks for the talk. One question that I have is regarding key management. So let's say, what the problem that I see is similar to client certificates in SSL, right? You maybe have a client certificate in one browser, but me personally, I'm working on 4 computers frequently. So on my work computer, at home, on my tablet, and on my smartphone. How do I get, and with your key management, I guess it's the same problem. How do you get the keys distributed over all your computers, over all your devices, over all your browsers? Yeah, so a lot of the use cases we're aiming at, ephemeral keys. Short-lived keys are generally better for many reasons, and that's a lot of what people are planning to do with this. There was some thinking about solving a lot of problems that you wanted to solve on a standards level, so we can imagine there's a separate key storage place. We have some idea about how we want keys to be synced across multiple devices. And in fact, if you look at the W3C's architecture diagram for this space, which I drew, there is indeed, we want this to happen across browsers. We want identities to be transparent across browsers. We even hosted a workshop asking the browser vendors, wouldn't this be great? And Mike Hansen Mozilla has done a lot of great work on this already, and he's left, unfortunately, but we know it's possible, and the guys from Chrome were like, yeah, it's probably possible, maybe you could do this. At the same point, we don't have consensus on that yet, to even start doing multi-device key management. Now, in-browser key management for a single browser, something slightly different. Again, we're putting things in structured clone. Think IndexedDB. The reason we're doing that is because you could also imagine long-lived keys being, from a privacy standpoint, worse than cookies. If there's a magical kind of thing which never goes away, which everyone can access, which can track you forever, you can imagine what this will be used for. We decided that it would be better to put keys into space, something like IndexedDB, because they would essentially, users could, even though we understand managing keys is tricky, and we hope the browser vendors develop nice, hopefully better than client certs, ways of tracking which keys you have and who's put keys in your machine and and what their lifespans are. And we do have these kinds of attributes. At the same point, we also want people to be able to clear their keys. And that goes against having that's why we decided to put things in sort of IndexedDB, to keep the lifespans at least and the privacy controls at least in one place, not make them actively possibly worse. So again, a lot of the long-term key management stuff will come down to browser-specific decisions, which involve user interfaces, which we don't control. We're interested in this topic. If browser vendors agree, we will do our best to help.
We have 2 questions left, and we're going to cut it short because there's only 2 minutes left. First one here.
I was wondering if the working group was also giving guidelines to developers that are working on web applications today to facilitate the migration towards using such API tomorrow? Because people are doing crypto inside of browsers, and how they're doing it is through libraries mainly, and some of them have also design flaws in them. And do you provide like guidelines that are like, for example, if you are doing crypto, you should never serve content that contains HTML from your web application. You should only communicate through some sort of serialized format like JSON or things along these lines.
So there are, okay, so if we have time, a primer would be nice. The specification itself, remember, we're allowing people to do quite bad things in the specification because it's a low-level API to give people capacities to build backwards compatible things. Thus, RSA, piece, we do want people to do the right thing. We are trying to figure out where we will put that in security considerations in some abbreviated form, and we ideally will reference the people who really are tracking what crypto is broken and what's not. And we will also, of course, track with WebAppSec a unified web security document, which I think a lot of the questions that people actually have about web crypto are actually not about crypto itself or the API, but are actually larger questions around sandboxing and And this is more of a general web security, WebAppSec working group problem. And for the specific library migration issue, this is tricky, right? Because there's lots of different libraries out there. And there's at least 5 or 6 I know off the top of my head. We try to get people involved in those libraries in the working group. So for example, a lot of people are using the Stanford JavaScript crypto library. It's a very nice one. You can't get better. On many levels at the same, and we have Emily Stark from MIT is part of the working group, and she's one of the designers of that API. I'm hoping that she would help people with migration advice, but migration advice for specific libraries is probably out of scope for the working group, but we do hope that libraries provide this to their users. And I guess, is that the last question, or is there another question?
There's one more question here, real short. That's from the gentleman in the middle here. Can you please stand up?
So, yeah, the basic idea is, I think you have to make sure you get the basics right, because that's the idea, right? So perhaps being able to access a private key after it has been written once is something which is probably not a very good idea in crypto. That's what HSMs and smart cards are trying to prevent physically, and you should try to prevent that by all means in software if you can. There's no legitimate use case for that. You make a temporary key which you sign with the real private key in case you need that use case. And the other thing is, there are lots and lots of technologies you can recycle. So like every decent operating system has a key management, has a good store. That store can be replicated for the lady which was on earlier between devices in case they're compatible. So I think, a good design is not one where there's nothing to add anymore. There's one where there's nothing to take away. How open is this? Like, if we give this type of feedback, is that still possible, or has kind of Google designed it to the point where they have their use cases, which are not described here, and basically, that's what they need?
Well, again, I mean, interestingly enough, I think what you described is actually what we're trying to do. So, we have the people, for example, watching the mailing list, like Brian Lamake, who are involved in the Microsoft Next Generation Crypto API. And we believe that, when this API, again, we're not making new crypto. We're just exposing existing, often which will likely be, particularly in the case of Microsoft, OS-level routines to JavaScript. Just to clarify that point. As regards how locked down it will be, well, it is a standard, right? It's not locked down now. That's why I'm here. So we want as many different use cases. We have a very open process here. You can just use a public mailing list, join a mailing list, put your use case out, put your concerns out. I'm concerned because we don't have enough independence doing that. We have minus Apple, all the browser vendors in the room. We have a lot of companies, a lot of security companies. We don't have enough independence. We don't have enough smaller companies providing us review and feedback use cases. And again, standards are standards. There will be, if this one locks people down in a way which they're uncomfortable with, there will be another version. CSP is already on 1.1. I would be shocked if there was another version of this once it got out there. But again, the more feedback we have now, the better we can make it. And right now, things are kind of wide open. But then they won't remain wide open this time next year. So that's why we want the feedback now.
let's give a round of applause for Harry Halpin.